Okay, trig revision test. Here we have the function here. To do the derivative, you do the derivative of the x squared first and get 2x, and then you do the derivative of cos x, which is minus sin x. Now this is all on trigonometry, so the extra derivatives are coming from this part of the table. You can see that the derivatives of this section are sitting there on the bottom. The derivative of the sine is cosine. The derivative of the cosine is minus sine. When you've got a function, the derivative of the sine of the function, it's the same as the cosine, but you've got to have the f dash out the front, the derivative of the bag. And when you do the derivative of the cosine of a function, it's the negative sine, but once again, derivative of the bag, f dash out the front. So we're applying that to here. This one's e to the sine x, and that is like e to the f. If you go back to the table, e to the f, we're using this rule here. That's f dash e to the f. So f dash is the derivative of f, and that's cos x out the front, f dash e to the f. This one here is cos squared. So cos squared actually means cos x all squared, and so this is like a function to a number. So if we look back here, function to a number is like this one here. So you got to bring the number out the front, take one off the power, follow up by the derivative of the function. So we bring the number out the front there, and you take one off the power and you follow it with the derivative of the function. This one here is the product rule between ln x and cos x. So there's the derivative of, you've got to go u dash, I'll just show in the notes again. The product rule is here, so that's u dash, sorry, that's not it. The product rule is here, this one here, so it's u dash v plus uv dash. So here we do the derivative of the ln, leave the cos, leave the ln, derivative of the cos. So that's really u dash v plus uv dash. This one here is, you could do a quotient, or you could change it. Probably best not to do quotient, because that's not a function on a function, that's not a function there. Quotient is u on v, where u is a function, v is a function, but we've got a number on that. So it's probably best to bring this up to a power. Now square root is a half power, but if it's on the bottom it's minus a half. So that's the function rewritten. And then to do the derivative of that, we use the same concept, function to an n, which is this one here. Function to an n, which is number out the front, take one off the power, followed by the derivative of the function. So the number out the front, take one off the power, and follow with the derivative of the function. Now the derivative of sine 2x is, the derivative of sine 2x, if you do the derivative of that, that's cos 2x, and then followed up by the derivative of that function, which is 2. So it's really a power rule within a power rule. Okay, now applications. We have the function there. That's periodic function. And first of all, we do the derivative of that. Derivative of not that is 0, and derivative of cos is minus sine. But you've got to follow it up with the derivative of the function, that bracket. I'll put it at the back this time, 0.507, and you got 6.8 out the front. Okay, now we want to know when it's what the derivative is at 8 o'clock. So when t is 8, if you put t is 8 into there, you'll get this value. Now this is saying the derivative is a negative value. The derivative is the slope. So if you've got something like this and the slope is going down, then if the slope is negative, then the function is going down, it's decreasing. Remember, if f is decreasing, that means f dash is negative. That's also in the notes. Go back here, which is sitting up here. it's increasing has a positive first derivative, so therefore it's decreasing if it has a negative first derivative. The rate of change in depth at 8 o'clock. We've already done the rate of change. That's what dd by dt is, and so you just have to quote it again. We've just worked it out. Just put the units in meters per hour. Okay, next one is a water trough. We have to show that the volume is given by that. To get the volume, we need to get the area of the cross section and then times by the depth, and the depth is 8 meters into the page. So to get the area of the cross section, we need to get the area of the sector, which is this bit here, and then we're going to subtract the area of the triangle, and that'll leave us the area of the water. So the area of the sector, that's over here, is half r squared theta. You'll always be given that as a formula. Theta is in radians. Now the radius is a half, because the diameter is 1, so that means the radius is a half. That's a radius, that's a radius, and that's a radius. So it's a half squared, so that comes out an eighth of theta. The area of the triangle is half AB sine theta, where that's A and that's B. In this case, A and B are both a half, so it's a half times a half times sine theta. So that's an 8 sine theta. Now to get the area of the cross section, we just do the sector, the big one, minus the triangle, the little ones. That's what this over here is. Then to get the volume, we times that area by the depth, so times by 8, and the 8's are all going to cancel when you multiply through, and that gives what we're trying to get in the question. Find the rate at which the angle is increasing. So we need to find d theta by dt, the rate at which the angle is increasing. That's the angle. If you ever do a rate, it's got to be d by dt. So we want d by dt of theta. Now we don't have a formula for theta, we've got a formula for volume. So let's just do the, we can do this two ways. We can do the change of volume with time, because we're given like the rate here, so it makes sense to be doing dv by dt. If we do dv by dt, we're going to do the derivative of that with respect to t, and then derivative of that with respect to t. So it's d theta by t, dt, and then you do the derivative of sine, which is minus cos, times by the derivative of the bag, the derivative of the function, which is d theta by dt. We can take that out as a common factor and left with 1 take cos. And we know that that rate is 0.1 because it gives it in the question. And now it's saying what is the rate of increase when angle is 90. So we put theta for 90. And we solve that. Cos 90 is 0. And so now we've got d theta equals 0.1. The other way of doing it, you could do use the chain rule and say dv by dt is dv by d theta by dt, because v is a function of theta. So to do the derivative with respect to time, first of all we do it with respect to theta, and then we do theta with respect to time. You can see they cancel out, it's really dv by dt. Now if you do dv by d theta, that's the derivative of this with respect to theta. The derivative of that one is 1. The derivative of that one is cos theta, so it's 1 take cos. So that's that bit done. And then you follow up by d theta by dt. Now we're going to put theta as 90, 1 take cos 90, and we're getting the same thing as on the left. So it's 1 take 0, and so we get d theta by dt is 0.1. Question 4 is a ladder. We need to show this formula here. We can do that using sine and cosine. The sine of theta is opposite over hypotenuse, xb, which is this formula. If you rearrange that, we've got xb. Cos theta, using this triangle here, is equal to adjacent. Now adjacent is 2, so it's adjacent over hypotenuse. Rearrange, it's that there. Now that we've got xb and by, we can add those two together, and we've got the total length of the ladder. So it's this one plus this one, which I've got written there, which is what we're getting in the question. Now we have to do the derivative with respect to theta. So we have to differentiate this thing and try and end up with that thing. So the first thing is express the cos theta and the sine theta as powers. So there it is to the -1, there it is to the -1. When you do the derivative, power comes out the front, take one off the power, fill up the derivative of the bag. Here, power comes out the front, there, take one off the power, follow up the derivative of the bag, which is that one there. And now put the -2 on the bottom, so it's cos squared, put the -2 on the bottom, so it's sine squared. And now we want to combine these using a common denominator. So we're going to times by sine squared on sine squared, cos squared on cos squared, and so we both have a common denominator, sine squared, cos squared, and that's what the question is. Part C, what is the length of the shortest ladder xy which touches that? So we want to minimize this, we want the shortest length. Now the shortest length is going to be when this equals 0, because the minimum L is when the derivative is 0. So that's what we've got here, and so this is going to be 0 when the top is 0. Fraction will be 0 only when the top is 0. So I've made the top 0, taken that over the other side, divide by 2, and cube root both sides, sine equals cos. Now that only occurs when theta is 45 if you think of the unit circle. Remember, the cosine is the x coordinate and the sine is the y coordinate. So if you've got a point like this, say 30 degrees, clearly the x and y, and that's the cosine, that's the sine, are not going to be equal. They're going to be equal at 45 degrees because then you've got an equal x and an equal y. So that is cos 45, comma, sine 45. Right, so when your two sines are the same, it's when your angle is 45 degrees. Okay.